Unit 13, Objective 5. Approximating areas and slopes of tangent lines using tables of values. Okay, so we have been doing slopes of tangent lines early in the unit, and then just in the last lesson we did some approximating of areas between the curve and the x-axis. But this time, not giving you the entire function, we're just giving you some snapshots of what's going on with the function. So let's just go ahead and dive right in. Given that y equals f of x is a continuous function on the closed interval from -3 to 24, and the slope function exists for every x on that. Now, by the way, I think the homework doesn't tell you all that explicit stuff, but really this is stuff that we understand that this is happening when we're giving you a table of values and asking you to do these things, that it's continuous and the slope function exists and stuff like that. So anyway, the table of values below shows 5 different points on y equals f of x. Now, because it's only showing us a snapshot here, we really can't do inscribed rectangles and we can't do circumscribed rectangles because we don't know if the highest point is either the left side or the right side or some other x value in between what's being shown. So when they're giving you a table of values, they're not going to ask you to do inscribed or circumscribed rectangles. They will ask you to do either left-hand rectangles or right-hand rectangles or midpoint rectangles. Now, left-hand rectangles and right-hand rectangles are much easier to deal with than inscribed and circumscribed because left-hand rectangles are simply telling you you're always doing the left side for the height. And if you're doing right-hand rectangles, guess what? You're doing the right side for the height. So it's actually a lot easier in many ways when we're doing left-hand rectangles and right-hand rectangles. Let's just go ahead and dive in. Okay, so now when they give you a table of values, they might be equally spaced. They do not have to be equally spaced. For example, take a look here. The x values go from -3 to 5. That's a jump of 8. And from 5 to 11, that's a jump of 6. And from 11 to 20, that's a jump of 9. And from 20 to 24, that's a jump of 4. So probably a lot of times they will be equally spaced, but they do not have to be equally spaced. So since we are doing rectangles, the areas are base times height. And so these differences in the x, those are the bases for each one of the rectangles. So for left-hand rectangles, notice I've got 4 bases, 8, 6, 9, and 4 from left to right. So my area is approximately, okay, base times height for each one. So my base for the first one is 8. And then I'm doing the left-hand side. Well, which one's the left-hand side for this interval? The left-hand side is the one on the left, which is f of -3. Plus, and then my next base is 6 times my next height. Now, which one's my left-hand side? The left-hand side is the f of 5. And then 9 times f of 11 and 4 times f of 20. Notice we never use the f of 24 because that's a right-hand side and we're doing left-hand rectangles, so yeah, we're not going to use the f of 24. We're using the left-hand side for each subinterval. Okay, so we have 8 times, well, f of -3 is 17, and f of 5 is 3, and f of 11 is 24, and f of 20 is 17. Okay, and so if we work all that out, let's see, we do get 136 plus 18 plus 216 plus 68, which is 438. That's just an approximation, and then we just followed the directions. We did 4 left-hand rectangles, and that's the area. It is square units. No units were given to us, so you don't need to worry about doing the units. Okay, moving on to number 2, or part B anyway. Very, very similar. The bases, I mean, it's the same table of values, so the bases are the same bases. Only this time, instead of doing the left-hand side, we're going to be doing the right-hand side. Okay, so base times height. Now, you know, you could say f of 5, it's notes. I'm going to do f of 5 right now, but you could possibly skip right past that step and do this next step right here. So let's see, 8 times, let's see, f of 5 is 3, f of 11 is 24, f of 20 is 17, and f of 24 is 12. Let's see, 144, 90 plus 63, 153 plus 48, which is 369. Okay, again, units are not there, so we don't need to worry about the units. It is square units, it's area. Okay. Find the best estimate. Okay, so that's the area. Find the best estimate for the slope of the tangent line to y equals f of x at. Okay, now, let me just kind of give you a little bit of background to this. If I want to find the slope at x equals 1, and let's say that x equals 1 is about right here, then, you know, it's like we kind of visualize the curve, and, you know, it's like here's the slope of the tangent line. But if we don't actually have the curve, we can't do the slope function like we've been doing. But what we can do is we can go equally spaced on either side, and the best approximation will be the slope of the secant line that's equally spaced on either side of the x equals 1 in this case. Okay, so if we want the best estimate for the slope of the tangent line to y equals f of x at x equals 1, well, where is x equals 1? X equals 1 is obviously in between -3 and 5, and in fact, 1 is right there in the middle between -3 and 5. The average of -3 plus 5 is 1. Okay, so using those 2 points right there, the slope at 1 is approximately f of 5 minus f of -3 over 5 minus a -3. So I'm just doing the slope of the secant line that is equally spaced on either side of where I'm trying to find the tangent line. And so we get 3 minus 17 over 5 minus a -3, which is 8. And that is -14 over 8, which is -7/4. Okay, well, let's try that one more time here. So at x equals 8, well, where is 8? 8 is in between 5 and 11. And in fact, is it right in the middle between 5 and 11? Well, the average of 5 and 11 is 16 divided by 2, so 8. So it's right there in the middle. So the slope for at x equals 8 for y equals f of x is approximately f of 11 minus f of 5 over 11 minus 5. We're just doing the slope of the secant line on either side, equally spaced on either side of that, and that will be the best approximation we can do for the slope of the tangent line. Okay, so f of 11 is 24, f of 5 is 3, over 11 minus 5 is 6, 21 over 6, which is 7, no, not thirds, 7 halves. I'll fix that. 3 goes into that. Okay, so 7 halves. Okay, so really that's what the notes are about, but we need to practice just a little bit more here. So I have another function given to us. Different function, y equals g of x. It's continuous and the slope function exists. Okay. Here's a table of values. Notice that this one is actually equally spaced this time. So from -6 to -2 is 4, from -2 to 2 is 4, 2 to 6 is 4. It's a spacing of 4 each time between the x's. Okay. So approximate the area below y equals g of x, but above the x-axis. So it's always the area between the curve and the x-axis. Using two right-hand rectangles, only two rectangles, with equal bases on from -6 to +26. Okay, so that covers the entire length of the table. Okay, now, equal bases. Okay, now, a lot of times you can just kind of count it out and look at it, but sometimes it's a little bit of a pain. So if they're talking about equal bases particularly, it's kind of nice to realize that you can do delta x is equal to the b minus the a over the number of rectangles. Now, what's the a and what's the b? Well, a is the first value here on the left, and the b is the second value here on the right. So b minus a divided by the number of rectangles. So in this particular case, delta x is 26 minus a -6 over, we want 2 right-hand, so number of rectangles is 2. So that is 32 over 2, which is 16. Okay, so the base of each rectangle is 16. Now, probably you could just kind of count it out, and you don't have to do that very formal formula, but it's kind of handy at sometimes. So let's keep that in mind. So if I start at -16 and I go 16 to the right, let's see, -6, if I go 16 to the right, that ends me at 10. So here is a base of 16. And then I pick up right where I left off at 10, and if I go to 26, is that also 16? Yes, it is. That's good. So I've got two rectangles of equal bases, and it covers the entire interval that we're looking at. So our area is approximately base times height, so the base is 16. Okay, and now remember, right-hand rectangles, so 16 times f of, now I got to do the right-hand side for this interval, and so it's f of 10. Okay, that's the first rectangle. Second rectangle, base of 16, and then the right-hand height, so all the way to the right-hand side, so f of 26. Now, when we are doing equal bases, it's kind of nice sometimes to go ahead and pull out that GCF of the equal base. And I know since there's only two of them here, it's not that big a deal. But it is kind of nice when you have several of them. So if you have equal bases, it's kind of nice to go ahead and just pull out that GCF of the equal base. And then that just leaves you with f of 10 plus f of 26. Now, you can only do that when the bases are equal. So like up here on the very first problem, since the bases were not equal, we really could not do that GCF thing. But anytime the bases are equal, it's kind of nice to do that. And you can probably just skip right to that step right here. Okay, so we have 16 times, well, f of 10 is 19, and f of 26 is 14. So we're doing 16 times 33, which is 528, is that right? Okay. Yeah, 528. Okay, so approximate the area between y equals g of x and the x-axis on the closed interval from -6 to 26, so it covers all the x values in my table of values, using three left-hand rectangles with bases of 4, 20, and 8 from left to right. Okay, well, my bases are not the same, so we're not going to worry about that GCF thing. But if I start at -6 and I do a distance of 4, isn't that just right there to -2? So then I've got to do a base of 20, so I pick up right where I left off, and I got to go to 20. So -2 plus 18 is 20, so there's my base of 20. And now if I pick up right where I left off at 18 and go to the end, is that a base of 8? Yes, it is. Okay, so there are my three bases for my rectangle. So my area is approximate. Now again, it's not the same base, so we don't have to do the GCF thing. Yes, there is a GCF of 4, but if you want to do that, you can. But I would say if you only do it, pull out the base if it's the same base all the way across. So base times height, three left-hand rectangles. So I've got 4 times f of -6 plus 20 times f of, well, the left-hand side is at -2, so f of -2 plus 8 times f of the left-hand side, f of 18. So we've got 4 times, well, f of -6 is 7, f of -2 is 10, and f of 18 is 23. 23. And so if we add those up, let's see, we have 28 plus 200 plus, let's see, 160, 184. So 28 plus 200 plus 184, which is 412. Okay. Approximate the area between g of x and the x-axis on -2 to 22. Now wait a minute, -2 to 20, that's not the entire interval here. So we are not using the -6,7, and we are not using the 26,14. So we always got to pay attention to the interval that they're talking about. 3 midpoint rectangles. And that should be saying with equal bases. So I apologize, I left that off with equal bases. That was supposed to say with equal bases. Okay, so since it's got equal bases, now like I say, we could probably just kind of count it, but let's go ahead and use that formula again just for the heck of it here. So delta x is b minus a divided by the number of rectangles. And so now again, remember here, here's a, here's b. So 22 minus a -2 over, we want 3 rectangles, distance of 8 for each one. Well, if I start at -2, here's a distance of 8. Here's a distance of 8. And here's a distance of 8. And that covers from -2 to +22. Okay, so my area is approximately, okay, now, remember how we have equal bases here? So, all my bases are 8. So, base times height, here's my base, GCF out in front. Now, midpoint. What's the midpoint for each one of these subintervals? Well, from -2 to 6, the midpoint is going to be at 2. From 6 to 14, the midpoint is going to be at 10. From 14 to 22, the midpoint is going to be at 18. Okay, so f of 2, f of 10, f of 18. Okay, so, and if we distributed the 8, obviously we have base times height, base times height, base times height for each one of those. But it's nice to, if the bases are equal, to go ahead and pull that out. Now f of 2 is 9, f of 10 is 19, f of 18 is 23, which is 8 times, let's see, 28 plus 23 is 51. Times 8 is 408. Okay, finally, approximate the slope of the tangent to y equals g of x at x equals 0. Write the equation for this tangent line. Okay, we did practice on this on the first problem, so we're just going to do that real quick. Let's see, at x equals 0. X equals 0 is right in the middle between -2 and +2. And so we're going to use these 2 points right here, -2, 10 and 2, 9. So m of 0 is approximately g of 2 minus g of -2 over 2 minus -2. Well, g of 2 is 9, and g of -2 is 10. 2 minus a -2 is 4, so -1/4. Okay, and write the equation for this tangent line. Well, guess what? We need to know the point at x equals 0, and I did not give that. So let's say, sorry, if g of 0 equals if g of 0 equals 7, let's say. Okay, sorry, I did not give that original information. We need that information right there to be able to do it, because we need the slope and a point. So our point is 0, 7, and the slope is -1/4. And so our equation, y minus 7 equals -1/4 times x minus 0. But remember, we don't leave zeros. So y minus 7 equals -1/4 x. Technically, you could leave it like that, but probably it's kind of nice to go ahead and move that -7 over.